This video will show you how to use the graphing sticky in Classpad.net to graph a hyperbola. So I'm in Classpad.net and I just have some reminders up here. A horizontal equation, the standard form for hyperbola is here. So it's x minus h is in the first term. If you want a vertical hyperbola, it's in the second term. We're going to look at these in just a minute. But let's say I just am asked to graph a hyperbola. One thing, if students are learning about standard, they could look at this and say that this is definitely going to be a horizontal because the x minus 3 version comes first. So all we're going to do is get out a graph sticky. So I'm going to click anywhere on the screen. Here are my options. I want the graphing one. So when I click that, that opens a graph for me. And I'm going to just move it over here so I can see it and kind of see my equation at the same time. One thing when you're graphing with Conics is you want to make sure the graph sticky has turned on Conics. So settings up here is where you can change the settings of any sticky you're in. So when I click the 3 dots, you'll notice in the graphing I can turn on Conics. I want to make sure I do that before I graph any Conics. So any ellipse, circle, hyperbola, parabola. And what that's going to do is allow you to see the key points, so the foci, the directus, asymptotes if there are any, those types of things. So now I'm just going to get my function. So here's my graph. I'm going to hit f of x because I'm entering a function. And here's the function I want to enter. I can copy and paste this, or I could just use my math templates here. So let's just do that first. So we're going to x minus 3 squared, and I'm using my keyboard, but you could also use your soft keyboard here. Oops, I want to make sure I make this be, let's erase that. I want to put the template on first, and now let's do y plus 2 squared, and then 9. So if we compare this equation to our standard form, our a term, this is a squared, so our a term must be 2, and our b term 9 is 9, so our b term must be 3 because 3 squared is 9. So that's one thing to kind of help students kind of look at, and where does that appear in our equation. So once I've graphed it, so notice all I did was just type in, I've turned Conics on, and now it's going to graph it. And it looks like we could even make our graph a little bigger so we can see everything. So let's look at this graph and let's see what are some things I noticed. So once Conics are on, when you click this, you're going to see some key things. So you're going to see some key points here. So let's look at this. We've got a point here at 3, -2. Well, what did we already talk about? We talked about, we hopefully know that our centers are identified by this h and k term. So our center's at 3, 2, so h must be a 3 and k must be a -2. Our asymptotes, if I were to click on them, they are defined here. That's the equation for the left asymptote, and this is the equation for the right asymptote. What do we notice? This is some things we want to talk about with students. The slope is different, but the intercepts are the same. Not the same. They're also different. What else? Oh, and here, these points right here, what do we notice? Where are those coming from? So there's lots of things that they can pay attention to in this. What are some key features? Our intercepts. Notice it's in standard form. If you don't want standard form, all you have to do is change it to decimal form, and it will change them to their decimal versions, and that might be more helpful depending on the level of student that you're working with. So graphing an hyperbola is very easy. A couple things to remember. First, turn on Conics, and then just enter your function as you would, and then when you click on it, you can see the key features of the hyperbola. What I also want to show you is that you can use this graphing capability to help students understand hyperbolas by using sliders. So I'm going to slide this down here, and I'm going to open a different graph. And I'm going to show you that if you have the standard form, so notice this for horizontal and vertical, we can actually use these letters, H, K, A, and B, as variables, and they create sliders. So let's do that. We're going to open another graphing sticky. Let's remember to turn on our Conics. Right? And now we're going to graph two functions. We're going to graph both of these equations so that we can see the difference. But the difference here is I'm not going to use my numbers. I'm going to use those variables here. So I'm going to, and I'm going to just copy and paste this time just to make it easier on myself. So I'm going to select all of this, Control copy for me, and then I'm going to go into my equation sticky, and I'm going to Control V or paste it. Whoops, I didn't go into my sticky correctly. Let's try that again. There we go. And now when I hit enter, it's going to graph that hyperbola. But notice what it did. It created sliders for those A, B, let's get rid of this. It created sliders for those A, B, H, and K, and now students can really discover what does that mean. So let's just click on the current values and see if we can notice anything. So here's this center point, 1, 1. Well, that doesn't help me very much. Where's that coming from? Is that A, is that B, is that H, or is that K, since they're all 1, 1? So now maybe I want to play around with something and see what's happening. Let's maybe make, let's make a 0 and see what happens. And hopefully it's going to give us that message that we're looking for. And uh-oh, my hyperbola disappeared and I have an error. Well, that's because I can't have an A value of 0. So that's a really fun thing to experience with students. So let's make A go back to being a good number. Let's make it be 4. And let's see what happened to my hyperbola. Uh-oh, look what happened. So where is that 4 showing up? If I click on it, let's try to explore. Let's make H be -4. What happened? Uh-oh, I don't even see my hyperbola anymore, so maybe I need to make my graph zoom in a little bit so I can see it. And there's my hyperbola. So now where did that 4 come from? So let's look at our center point. Oh, there's my -4, and H is -4, so the center must have something to do with H. And so then they can start exploring. So you can create sliders very easily. So let's have a center at 0. Let's make that 0. Can I have a center at 0? Yes. And let's make A be a little bigger. Let's move it to 2. Let's make B be a little larger. So there's lots of things you can play around with here, and let's explore the center at 2. So how does that work? So lots of things you can do once you have sliders. And now, because I already have these sliders, I can actually now make the vertical image of this as well. So let's do that. So up here, we're going to get a different color here. I'm going to copy and paste again. And I'm going to paste it into my second equation. And now I'm going to get the vertical version of the asymptote using those same sliders. So now we can really explore which one of these variables controls the center of my hyperbola, which one controls the foci. How do I figure that out? If I'm given an equation, how can I work with these numbers? If I put it in the standard form, how can I find center and where the foci are, how wide, how closed the hyperbola is. So lots of ways to explore. You can just graph if you have an hyperbola equation, making sure you turn on conics, or you can explore and try to understand the different components of a hyperbola equation by playing around with sliders.